Okay, it doesn't take a whole lot to see that the condition for a relative max or min, and I call that a relative extremum along the curve, is that the gradient dotted with the unit tangent vector be 0, because this is the directional derivative. This means that the function is not tending to change, either increasing or decreasing, at that point. Okay? Now there's a little more to it, but this is the main condition. And you can read your book and get the rest of the conditions. So the gradient would have to be parallel to the normal vector, right? Because the gradient's got to be perpendicular to the tangent direction. Otherwise, the dot product is going to be non-zero and the function will be increasing or decreasing. And of course, the unit tangent vector is perpendicular to n, so del f has to be perpendicular to n. So you either have this picture with del f in the direction of your outward unit normal, or del f in the direction directly opposite that unit normal. Either way, you have a condition that is necessary for the point to be a relative max or min. Okay? Now the question is, how do we get the unit normal? Well, we're going to put it this way. This curve is a curve in two-dimensional space. It's going to be some expression in terms of x and y, maybe equal to constant, or it's going to be described by an equation in x and y. Well, we can bring that entire equation over to one side and maybe have constants on the other side, so that the equation becomes an equation in the form g of xy equals c. Now we note that that is a level curve of some function g of xy. Okay? If the curve is this, then its gradient is normal. Okay? Because the gradient is the direction of maximum increase in the function g of xy, and this is a level curve. That's the direction in which the curve is, the curve is in a direction perpendicular to the direction of maximum increase. And we've talked about that, so that's something you should understand well now. If not, give it a little more thought. Okay, so del G is going to be our normal. So instead of n here, we can replace n with del G, the gradient of G. Okay? And then I make a comment here. I say G doesn't change along the curve. G of xy equals c. Del G is the direction of maximum increase of G, so del G has to be normal to the curve. That's your argument, but you need to make sure you understand it. Okay? So a condition for relative extremum is going to be del f parallel to the normal vector, because they're both perpendicular to the unit tangent, which means it's parallel to del G. So that del f is a scalar multiple of del G. Okay. Because what's it mean for two vectors to be parallel? Well, I asked the class, first statement was, well, their cross product is 0. And I said, that's good, that's true, that's great, but there's a simpler way to do it. What's a simpler way? So I kind of half expected to say, okay, the dot product is equal to the product of the magnitudes. Okay? But that's just about as complicated as a cross product, so I'm not sure that's going to be helpful. Although it would be if you were doing this in more than 3 dimensions, because a cross product isn't defined in more than 3 dimensions. But the simplest relationship is two vectors are parallel if one is a scalar multiple of the other. If and only if one is a scalar multiple of the other. So your relative extremum occurs if del f is some multiple of del G. And the letter that's used by almost everybody in the universe, as far as we know, for the constant is lambda. Okay? I ask people what to use for the constant, and when to use C. Well, that's not good, but kind of used it here. How about A? Good. How about alpha? Well, lambda. And then as that reminds us of eigenvalues. Yep. And then I speculated on whether this whole situation could be modeled by linear transformation, and that the eigenvalues would somehow correspond to this. And I haven't thought that through, but it's kind of an interesting thought, and it wouldn't be that difficult if you really have a good command of linear algebra and molecular calculus. So if I have time, I'll think about that. Probably late at night when I'm having trouble sleeping, because it'll probably put me to sleep. Okay. Well, there's our condition. Okay. Now there's a little more to it. You know, it's a relative extremum requires this. There might be other conditions, and you can read about those conditions and deal with them if they exist. So, encouraged to read your book. But the whole method is, the crux of the method is that del F has to be a multiple of, scalar multiple of del G. Okay, so now we're going to go ahead and do an example.